Okay, this is concept 49. This is the final concept in our unit. In this one, we discuss the ideas of exponential growth, exponential decay, and compound interest. So, the first formula is exponential growth. This occurs when a quantity exponentially increases over time. Here's the formula. It might be familiar because you might have worked with some very basic exponential growth ideas in middle school or maybe in 9th grade. You got A times 1 plus R to the T. A is your initial amount, R is your growth rate, and T is time. So it's very just plug and compute style problems. So for number 1, it says the original value of an investment is 1800. So A is 1800. If the value has increased by 7% each year, write an exponential function to model the situation. So R is 7%, and you're going to represent this as a decimal. So you have 0.07. That's 7%. And then finally T is 15 years. So 15 years. And then you just plug into our formula here. So you have F of 15, because T is 15, is equal to 1800 times 1 plus R to the 15. And then simplify, you get 1800, and you get 1.07, that's 1 plus 0.07 to the 15, and then use your calculator here, and then when you use your calculator, you're gonna find that it's equal to 4966.26. Whoops, 0.26. And that's it. That would be your answer. For number 2, it says in 2002 there were 972 students enrolled at Oakview High School. So A is 972. Since then, the number of students has increased by 1.5 each year. So rate, again represented as a decimal, this would be 0.015. That would be 1.5%. And then it says write an exponential function to model the situation, then find the number of students enrolled in 2014. So T, we have to think. They tell us the initial amount at 2002, and they tell us that they want to know what's the total number at 2014. So 12 years has passed. So T is 12 years. So now we plug these into our formula. We have F of 12 is equal to 972 times, then you'll have 1 plus, you would have 1 plus 0.015. So this is 1.015 to the 12, and then this is what you put in your calculator. You can take it a step at a time if you want, or just input it all, it'll still work out. And when you do this, you're gonna get you get 1162 students. You get a decimal, but of course you can't have part of a student, so just round, and then you get 1162 students. The next one is exponential decay. This occurs when a quantity exponentially decreases over time, and whoops, it's minus. Okay, so it's F of T is equal to A times 1 minus R to the T. The variables stand for the same thing, except R in this case would be a decay rate. So number 3 says that an investment of $12,000 is losing value at a rate of 4% each year. So A is 12,000 and R is 4%, so 0.04, and T is 9 years. So plug in, we have f of 9 is equal to 12,000 times, it'll be 1 minus 0.04, and when you do this, you'll get 0.96 to the 9. Then put this in your calculator, and you're gonna get you're gonna get 8310.41, and we're talking money, so $8,310. Number 4 says Mark bought a brand new car for $35,000 in 2008. If the car depreciates in value approximately 8% each year, write an exponential function to model the situation. So A is 35,000. My decay rate is 8%, so 0.08, and he bought it in 2008. We're talking what's the value of the car in 2015, so 7 years have passed. T is 7 years. And then now we plug in. We have f of 7 is equal to 35,000 times 1 minus 0.08 to the 7. This is equal to 35,000. And if you do 1 minus 0.08, you get 0.92 to the 7. And then put this in your calculator, and you get you're gonna get 19,524.63, and then that's the value of the car in 2015. Finally, the last one is compound interest. This might be the more difficult one to remember. This one occurs when interest is calculated on both the principal amount and the accrued interest thus far. So it's A is equal to P times 1. A is equal to P times 1 plus R over N to the n T. And times T in the exponent. So P is your principal or initial amount, R is your rate, N is the number of times compounded. This should say, well, yearly, and finally T is time. So it's just more things you have to keep track of plugging in, but it works the same way as the previous two. So Laura has deposited $12,000 into an account that earns 8% interest. How much money will she have in 5 years if the interest is compounded quarterly? So the initial amount, or the principal amount, is 12,000. Okay, the rate is 8%, so 0.08. T is 5 years. Then I have compounded quarterly. How many quarters are in a year? There's 4. Okay, so N, the number of times compounded, is going to be 4. And then it's same, like I said, same way. You're just going to plug it in. So A is equal to P, 12,000, and then 1 plus 0.08 over 4 to the N times T, so 4 times 5. And then let's clean it up a bit. You're gonna get 12,000, and if you do 0.08 divided by 4, you're going to get 0.02. So this is equal to 0.02. So then 1 plus 0.02, you're going to get 1.02. And then that's to the 20th, because 4 times 5 is 20. And then do that in your calculator. And you get 17, we're talking money, so 17,831, whoops, 0.37. And that's your answer. Number 6 says Jack took out a 6-year loan for $25,000 to purchase a boat at a 4.5 interest rate. If the interest is compounded monthly, what will he have paid total over the course of the loan? So we could say T is 6 years, right? It's a 6-year loan. P is 25,000. The rate is 4.5%, so that's 0.045. Ignore the helicopter, guys, if you can hear it. And then it's compounded monthly. How many months are in a year? 12, so N is 12. So plug in and you get 25,000 times 1 plus 0.045 over 12, and that's to the N times T, so 12 times 6. Let's clean it up. If you do 0.045 over 12 in your calculator, you're going to get 0.00375. So 1 plus 0.00375, you're going to get, you can keep all the decimal places just for the sake of accuracy. So 1.00375, 12 times 6 is 72. And now put that in your calculator, and you're going to get you're going to get 32,732, and we're talking money, so money sign, dollar sign, 5.58, and that's going to be your final answer. Number 7 says an investment account pays 3.9% interest compounded semi-annually. Okay, so let's underline that for now. And if $4,000 invested in this account, what will be the balance after 12 years? So R is 0.039%. P is 4,000, and T is 12 years, and then semi-annually means twice, right? Twice a year. So N is 2. So then A is equal to 4,000, 1 plus 0.039 over 2 times 12. And then let's clean it up. If you do 0.039 in your calculator, you're gonna get, divided by 2, sorry, you get 0.0195. So 1 plus 0.095, you get 1.0195 to the 24. And then do this in your calculator. You get 1.50. Okay, let's, before I do that, before I round, let's multiply it by 4,000. So you're gonna get 58.48. So that would be the balance after 12 years. Number 8, The savings account offers 0.08 interest compounded bi-monthly. If Bob deposited $300 into his account, how much interest will he earn after 10 years? So R is 0.08, P is 300, T is 10 years, and then N, it says compounded bi-monthly, so that's twice a month, and there's 12 months in a year, so it would be 24 times in a year. So N is 24. So I get A is equal to 300 times 1 plus 0.00, whoops, not 0.008, 0.08 over 24, and then oh, I messed this up. Okay, it's an eighth of a percent, so this guy is incorrect here. He should be an eighth of a percent would be 0.008. So then, yeah, this guy here should be 0.008 over 24, and then that would be 24 times 10, and then to get a really small decimal, you're gonna get a really small decimal. So just, I would say, calculate this in your calculator, add 1 to it, okay, and then you're gonna get some answer, and then raise that to the 24 times 10, which would be 240. You get some number, and then multiply that by 300. You're gonna get 324. You're gonna get 324.98. Finally, last one, we have it says, suppose you invest $750 into an account that pays 3% interest compounded weekly. How much interest will you have earned after 20 years? So P is 750. Oops. And R is 3%, so 0.03. It's compounded weekly. T is 20 years. So, and if we compound weekly, how many weeks are in a year? You can Google this if you weren't sure, and it's 52 weeks. So, and it would be 52. So plug this in. A is 750. 1 plus 0.03 over 52 to the 52 times 20, and then that's going to be another small decimal. So if your calculator is reading like it's telling you e to the -4, in other words multiply 10 to the -4, I would say just calculate that, let the calculator give you the whatever value that is, add 1 to it, you get something, okay, then raise that to the 52 times 20, you get some value, and then multiply that by 750, and you should get yeah, you should get 1366.35. Okay, and this wraps up the unit and concept 49.